she gonna geek out on us? I want her to geek out on us.
She'll geek. She geeks. She has the capacity to geek.
Okay.
We are Sex Bomb! 1, 2, 3, 4! Hello and welcome. Hi Natalie, my usual.
Hello.
Hi, today we have our special guest, Alison Pill, an actor.
Hello. Hi.
Hi! Thanks for doing math with us today.
I'm really excited.
I heard that you kind of like math, or you want to like math.
I really wanted in high school to be better at math than I was. I was like a solid 83% student kind of thing where I could get most of it right, and then any question that had not been provided as practice, I was like, nope, don't know.
Our students can probably relate.
Mm-hmm. Yeah.
Yeah.
And then like that odd test question where you're throwing and you're like, if you really understand it, you'd be able to extemporize, and you'd be like, no, can't.
Yeah. Okay, so that was the line. You knew.
Yeah, that was my line.
Cool.
Mm-hmm.
All right, we're going to try to take you past that today.
To real comprehension. I'm thrilled.
Oh, yesterday I did a deep dive. I gave you a goog, and I was like, ooh, she's in one of my brother's favorite movies because he loves Scott Pilgrim.
Oh, cool. Yeah.
That was adorable.
Yeah, it's
okay.
10-year anniversary. It's crazy.
Oh, it is? Yeah, 10 years, huh? Okay.
Yeah.
Perfect timing. Good. Are you down to do a quick little stats one on your sex bomb? Why is it called Sex Bomb?
It's just their name. It's just the best band name ever.
That's great. Do you really play the drums?
I learned how to play for the movie. Well enough. I mean, I learned basic drumming.
That's
awesome.
That
I could, yeah.
That's fun.
It was really fun.
Yeah, it looked really fun. Like the two bands, Sex Bombs, versus Crash and the Boys. You guys had kind of differing lengths in your songs during the Battle of the Bands. So fans started wondering, are all their songs that different in length? Are Crash and the Boys' songs always shorter or different? Or was that just kind of what happened that night? You know?
Right.
These are serious issues that I know our students think about.
Yeah, so you wanted to do a little statistics examination of Sex Bomb versus Crash and the Boys.
I mean, I think we have to.
I think we needs must. Yeah.
Look at little Allison. It's so good. I'm obsessed with your hair. Yes. Okay. So, Allison, we're going to do a little, I don't know if you've done any statistics analysis in your life or on the streets or on the weekends.
I mean, a lot on the streets mainly, but that's just me.
Yeah. But so I was thinking maybe, do you want to dive us in and talk us through what's the scenario here and help us out? Let's analyze this with you in charge.
Great. Let's do it.
Okay, let's do it. What's going on in this problem?
In the 2010 hit motion picture, hit's a strong word, but sure, Scott Pilgrim versus the World, rival bands Sex Bomb and Crash and the Boys battle it out on stage in an epic battle of the bands. Crash and the Boys begins with their 0.25 minute long song, I'm So the Sad, So Very, Very Sad. Sex Bomb starts with their 1.75 minute long hit single, Garbage Truck, which really is an awesome song.
It's so good.
Fans began to wonder if the two bands' songs always tend to differ so dramatically in length. Wallace exclaims that it's not a race after Crash's first song. In a random sample of 7 songs by Crash and the Boys, the mean length of a song is 1.56 minutes, with a standard deviation of 0.3 minutes. In a random sample of 10 songs by Sex Bomb, the mean length of a song is 1.8 minutes, with a standard deviation of 0.2 minutes. Assume that the length of songs from both bands are normally distributed. A. Construct a 95% confidence interval for the difference in the mean song length of the two bands.
Okay. A lot.
Easy enough.
I mean, you could probably do it in your sleep. So why don't we go ahead and look in at what's happening with our two samples. I'm going to use nice heteronormative blue for Crash and the Boys and highlight everything for them in blue. And Crash and the Boys, maybe we go ahead and call them hold on, let me make this a little nicer. Let's make them our first sample. So I'm going to call Crash and the Boys sample 1. If you are comfortable with that, ladies.
I accept it.
Okay.
Yep.
And then I'm just going to use different shades of blue for this band. Can you guys tell me how many, I'm going to write N sub 1 for the size of our sample. How many songs did we look at from Crash and the Boys?
7.
7 of their songs. So they have more than 7 songs, but we randomly selected 7 of them. And then, what was the mean length of those 7 songs?
1.56.
Right, and the mean we're going to use because it's the sample mean, so X bar 1.56 minutes. What other piece of information do we want?
We want
Standard deviation.
Yeah, we want standard deviation, and what was that?
0.3.
Right, and since that's a sample standard deviation, what symbol are we going to put here for that? Either one of you.
S1.
Yeah, it's S sub 1. And hey, Natalie, once we're using S, what do you know for sure is going to come in at some point in this journey?
At some point in the journey, T is going to come in because S and T always go together, hence stats.
Yeah, so Allison, we like to help our students remember anytime S comes up in life, really, then also, I feel like you probably are pretty comfortable with this, but I like to remind my students S and T are together in love. So somewhere along the line, T is going to play a role. We'll get to it. But
what role does the A play there? I mean,
it spells the word statistics, so it has to be there for this to be cute.
I just relationship-wise, like what does, I guess the A is kind of just like hanging out.
Oh, like emotionally? What is the
Yeah.
I mean, the A is kind of like a sister wife.
Great.
Yeah. We're open to all kinds of relationships.
I was just wondering because it's just like it seems like the A is like kind of like between two couples, but also of both of them, and I was just wondering about it. That's all. Cool.
She identifies as a she, and she's very fluid.
Great.
Okay.
Yeah.
I'm going to go over to, let's use orange for your gorgeous orange hair in this movie. And so Kim had gorgeous orange hair, and she was playing in Sex the Bomb, rocking it on the drums. Do you still play the drums?
No, it's really hard. It's a hard thing to just like randomly keep up, just because a drum set is an expensive, large piece of furniture to have with you. And at the time I was living in a New York City apartment, so I only ever had a practice drum set.
Oh, nice. Oh, you were living in New York when you filmed this?
Well, yeah, we shot it in Toronto, where I'm from. But
okay.
Yeah.
That's awesome.
Yeah.
I noticed the Canada setting, and I was like, I get it. I get it.
Yeah.
All right. Ladies, what is our sample size? How many songs did we look at from Sex the Bomb? The Bomb?
10.
10 songs. So what are we going to call that? 10 is?
And N sub 2.
Yeah. We just want to distinguish it. And Natalie, as we fill this out, there's a bummer because our sample size is not bigger than 30 on either of these. So that sucks for us, but there is good news because at the very end, the very last bit here, what do they tell us that we can assume?
That it was normally distributed. So that takes care of that.
Yeah, we don't even have to worry about our sample size because these models will mimic what the populations are doing, and if the populations are normal, the samples will be too.
Totally.
Yeah.
All right, everyone, we can breathe.
Great.
And then what was
also, it's highly doubtful that Crash and the Boys actually had more than 7 songs.
So this sample size, yeah, they were okay. I feel like they sing a song about hating people or we hate you or something, and I enjoyed that. That was a good one too.
Yeah, it's kind of my
Okay, what was the mean length of your 10 songs that we looked at in your band, Alison?
1.8 minutes.
Okay, so our X bar sub 2 is 1.8. And what was your sample standard deviation?
0.2.
Cool. All right, so I used all the different shades of orange for our sample 2. Blue is for sample 1. And what we want to do is construct a 95% confidence interval for the difference in the mean song length. So, like, of all of your songs, the mean song length of all of Sex the Bomb's songs would be mu sub 2. Like, your sample mean was X bar. Your population mean length would be mu sub 2. Likewise, with Crash and the Boys, their mean song length of all of their songs would be mu sub 1. So we want to know what is that difference, like, or create a confidence interval around what that difference is, like a lower bound and an upper bound. Does that make sense?
Yeah, I also just can never get over the fact that there's something called mu. It's just never going to not be funny to me.
Isn't it great? Mu.
Mu. Is it really?
Mu.
Mu. And it's so cute, and it looks like a little kitten face. And you're just like, mu.
I always, in class, I always go, I don't know about mu, like the Taylor Swift song, like I don't know about you, but I'm feeling, okay. Allison has already been my Taylor Swift problem.
Yeah, I don't need it. I don't need it.
Okay. I'm here for it. Okay, Allison, quick analysis of the 2 samples. Can you tell me what was the difference in the mean length of songs in our sample?
It is 0.24. No, what? Yeah, it is.
Yeah, if you take 1.56 minus the 1.8 minutes, we get the...
Yeah. Oh, negative 0.24.
Yeah. Okay. So whose songs were longer on average in these samples?
Sex the Bomb.
Yeah.
Sample 2.
Yeah, they had longer songs in these samples. But Natalie, does that mean that their songs are always longer?
No, not at all, because we could grab a different sample.
Yeah, what if we got 10 different songs from Sex the Bomb or 7 different songs from Crash and the Boys, if they had enough? So we need to get a nice little interval and say, okay, based on this negative 0.24 for our difference in our samples, where do we think that the difference in the population means would be? We are going to give ourselves a little buffer zone. What do we call that buffer zone, Natalie?
The confidence interval.
Yes, and what we're going to swing around both sides.
The margin of error.
Yeah, so we're going to swing a little margin of error around both sides to create that buffer zone and say, you know what? In our samples, the difference was negative 0.24, but we're going to leave some room. We could have been a little off in either direction on that. So let's give some room to that.
Right.
And so, Allison, while we were talking, I saw you working in your head there. Were you calculating our lower and upper bounds?
I was, yeah. We are 95% confident that the difference in the band's mean song length is between negative 0.5306 and 0.05055 minutes.
Cool. So for our students, they can see how to actually get this. Like, Allison's got this in her head, which, like, good for you. Girl power. But for our students, a lot of us are probably going to want to go to our calculators. And Natalie, what test do we need, or what command do we need to get this interval on our calculator?
So first you hit stat. I think you did that.
Oh yeah, sorry, I got excited. Stat.
Right. You got excited. So we did stat, then test, then we're looking for that 2-sample T interval. So there's where that T came into place.
Yeah, finally, the T in the relationship. So 2 samples, a T interval, and then we enter in all of our details from Crash and the Boys, all of our details from Sex Bomb. We want our confidence level. And the reason I wanted to demo this, even though Allison was doing it in her head, like a boss, is when we do it on our calculator, we do get asked this question about, should we pool? And ladies, when in doubt, do not pool. I cannot stress this enough. Okay? Someone comes up to you on the streets and they say, hey, should we pool our data? What are you going to say?
No. Hell no.
Hell to the no pool.
No, hard pass. It's never wrong to not pool, but sometimes it is wrong to pool. So little side note as I calculate is pooling means throwing all your data into one pool and treating it like one sample even though it's 2. And
No,
there's
thanks.
times when that's appropriate.
I need a prenup. Right?
You know? I need a letter of consent. There's all kinds of things. I agree.
Yeah.
But look we're getting the same interval that Allison obtained for us. So obviously in your head you weren't going in the pool either, so that's good for us to know about you personally.
Yeah. Yeah.
Great. So one last thing to know before we move on with our lives is what value, I know Natalie, you've been staring at this interval, and what value is on this interval for sure?
So for sure 0 is on there, which is special, right?
Yeah, we're going from a negative value to a positive value. So somewhere along the ride, didn't 0 have to be in here?
Yeah, exactly. And if 0's in there, what that means is that we're 95% confident that the difference in the song lengths, or the difference in the means rather, could be 0. So there could be no difference at all.
Exactly. This could be 0. I was going to write with an exclamation point because I got excited, but I was afraid it would look like 0 factorial, which would, yeah, so I'm going to calm down. Okay, so Allison can be quoted as saying all of this good stuff. Alison Pill, 2020, you're a coronavirus. Let's add that to your IMDb.
Yeah.
Let's look at part B. So, is there sufficient evidence that the mean length of the song differs between the 2 bands? Like, we did our confidence interval, but is that telling us that there is a difference between the mean length of the songs of the 2 bands? And we kind of already answered that there in green. We did that verbally.
Right.
But we can formally, we're kind of done, but we can just tell ourselves, we can structure this like a hypothesis test. Mm-hmm. And if we do, then we have already run the test with the confidence interval method.
Right.
What would be our hypotheses?
Our hypotheses, like the null hypothesis in this case, is that the mean length of the songs are the same. Right.
Right. So mu1 equals mu2. Mm-hmm. But in another way to say that, like mathematically, how could we also write that?
Yeah, if you wanted to, you could say mu1 minus mu2 is 0. That would be the same thing.
Yeah, if 2 things are equal, then their difference is 0. I like to write it this way because it's like more, it looks more like our old hypotheses with 1 sample.
Right.
But it's potato.
Totally. Okay, so the alternative would be that they don't equal each other, right?
Yes. Mm-hmm.
Right. So since we're just discussing differ, so what type of test would this be if we were actually like doing it all out by hand? Like left, right, or 2-tailed?
Oh, this would be a 2-tailed.
Mm-hmm.
Yeah.
So if we do look at the p-value method, whether we do that manually or we do it on the calculator, we'll see those 2 little tails.
Right.
First, let's go ahead and also note, by the way, we could write this as that their difference is not 0, because if 2 things aren't equal, their difference is non-zero.
Totally.
Okay, the confidence interval approach or method, we already did it.
Yeah, we did. And yeah, so basically that's just saying that if 0 is on the confidence interval, which it was, we discussed that, right?
Mm-hmm.
Recall that means we do not reject the null.
Right. So since 0 is on the confidence interval, we do not reject the null hypothesis because the null hypothesis says that that difference could be 0.
Uh-huh.
And so does our confidence interval.
Right.
It says could be 0. So why would we reject something that's lining up with our results, right? We don't want to reject that.
No.
So do not reject it. Now, we could, if we wanted a little practice, because I know it's your favorite method, the p-value method. We could go ahead and just get our p-value and compare it with alpha and see, just as we're learning, like, do we get the same result to not reject the null hypothesis?
Right.
So I'm going to use the calculator. I feel like by now we've done plenty of p-value method by hand, drawing, shading. So let's go ahead and look at the calculator for this.
Yeah, so we want that 2-sample t-test like we talked about.
Yeah, we did the 2-sample t-interval, but now we want to actually run a hypothesis test.
Right.
And luckily our data is all still here. Are we going to pool, ladies?
No.
No.
Hell
No.
no.
Two-tailed test, don't pool. Ooh, let's draw. Let's see the little two tails. Oh, they're not that little.
Oh, they're not.
Yeah. Wait for it. There she is.
Cute.
All right, so our p-value.
Yeah, 0.0952. Say alpha is 0.05.
How do you know that? Like, yes, it is 0.05. You did that very quickly. We weren't. Oh, we were given that.
Yeah.
Okay, even if we weren't given that, we could back up and look at, like, our confidence level was 95%.
Yeah, so the
Remember that?
Yeah, the complement is 0.05.
Yeah, which that's nice and straightforward when it's a two-tailed test. There is more to it when it's a one-tailed test, but we have the luxury of this being a two-tailed test. Our p-value, is it greater than or less than alpha?
It is greater than. So we're calling,
Okay.
yeah, and we're calling that means that we do not reject the null. So that's lining up with our confidence interval approach.
Right. We did not reject the null hypothesis there. We didn't here either. We could totally also do the critical value approach if we want to get wild. This is nobody's favorite method, but okay.
Yeah.
The difference in our 2-sample means was negative 0.24.
Yes.
And that is negative 1.8485 standard deviations from the null hypothesized value that difference should be 0.
Right.
So this is called our what?
Our test statistic.
Right. And we want to compare that to our critical value. So the critical value is T sub alpha over 2. Remember this, friend?
Yep.
So that's going to be T sub point, what do we have? 0.
2.5.
What do we have? Yeah, 0.5 over 2. So T sub 0.025. The other piece of information we need for a T-score is, remember, degrees of freedom?
Yes. So we get that.
But here's the issue. How do we have just one N?
No, we have 2. Yeah. So what are we going to?
Which one? Like, okay. Yeah. So the bummer is the degrees of freedom formula is actually really a lot, and like our calculator's doing it behind the scenes. So here's what the degrees of freedom formula looks like if you want to actually calculate it with 2 samples by hand. I don't have time for it.
No.
So a lovely mathematician named Welch told us that we could kind of do a little sneak, like just take the smallest n and subtract 1 from it, like err on the side of caution.
Right.
So of our two samples, what was the smallest sample size?
The smallest was 7. So then we'll say our degree of freedom is 6.
So yeah, 6. And then we can either use inverse T or we can go to our T table. Area 0.025, our degrees of freedom, 6.
Okay, so it's looking about 2.447.
Yep. All right. So our cutoff of how far away we can be is 2.447. So we're allowed to be up to 2.447 standard deviations away from the mean in either direction.
Mm-hmm.
We happen to be where we were. Our test statistic was negative 1.8485. So we are within that boundary.
Mm-hmm.
So would we reject the null hypothesis or not?
We would not. So again, that's lining up.
Correct.
I got a stereo. You just gotta turn the
Do it by hand. We have to kind of recall that if we were creating a confidence interval for a single mean,
Mm-hmm.
where sigma was unknown.
Yeah, we'll recall that that's X bar plus or minus
Cool.
T sub alpha over 2 and then times S over root N.
Right. So that's when we have one sample, and so one sample mean.
Right.
But now we want a confidence interval for a sample or mean of one population minus the mean of the other.
Yes.
And obviously, if we don't know those two population means, we probably don't know their standard deviations either.
Uh-huh.
So this is kind of always going to be the case. We kind of don't even need to say it.
Right.
What does that confidence interval look like? It's gonna really mimic it. Like we use our point estimate, but our point estimate instead of being a single X bar is now what?
It's X bar 1 minus X bar 2.
Yeah, and we're still swinging around a margin of error.
Uh-huh. That looks
Our critical value. Go ahead.
That looks a little different now, right? That margin of error.
Yeah, slightly. This part's the same, which is nice. We still have T sub alpha over 2.
Right.
But we do have to mess with the standard error a little bit. And when we combine two variables or two samples, even if we're subtracting, you can look here and it's very tempting to want to say, well, then we subtract their standard deviation. But even when you combine two variables, like with subtraction, you're still creating more variability. Mm-hmm. So what does our standard deviation, our standard error end up looking like now?
Okay, so now we still have that T sub alpha over 2, but this time the formula is going to change to the square root of S1 squared over N1 plus S2 squared over N2. So remembering that squared is an important piece here. And noting that it's all under the square root this time.
Yeah, and it kind of sort of like, not exactly, but like up here how S is not under the root.
Right.
And here how S is under the root, but it's squared, like that almost undoes it. Not quite, there's addition there.
It's
but it kind of
It's a way to remember it.
Yeah, I'm with you. Okay, so let's get our data from our samples, and we're going to just sub all these pieces in, and this just becomes a real quick little substitute. Put all your little pieces in now, right? So X bar sub 1 is at 1.56. What's X bar sub 2?
1.8.
And then plus or minus now, the thing you have to work for is that critical value. Like, we'll get to that in a second.
Yeah.
But all these other little pieces, so like S sub 1 was 0.3. What was N sub 1?
N sub 1 was 7. Then plus 0.2 squared over 10.
Cool. So there's our standard error And then our critical value is what we always have to work for, whether it's a Z or a T or it's a 1 sample or a 2 sample. That's where our work is.
Right.
Real quick, if our confidence level is 95%, then what is alpha?
Alpha is 0.05, the complement.
Cool. So T sub alpha over 2, T sub 0.025.
Yep.
The degrees of freedom is a big, nasty thing if we have 2 samples, because what's degrees of freedom usually?
Degrees of freedom is usually n-1, but this time we have 2 samples, so that makes it a little more complicated.
Yeah, because they're not even the same size. So it's like, you can't just take n-1. So what is our good friend Welch says is kind of a little sloppy, but we can still kind of squeak by if we do it.
Yeah, our friend says that we can just take the smaller one and subtract 1, so that's kind of like playing it safe, right?
Mm-hmm. So the smallest n-1 would have been 7 minus 1.
Yeah.
Which is 6.
Mm-hmm.
Okay, and then we go to our table, or we go to inverse T, and we get about 447?
Yeah.
2.4. So the 1.56 minus 1.8 was negative 0.24. Plus or minus, we need this whole margin of error. I'm getting like 0.3177.
Yep, that's what I got.
Cool. So what you'll notice happens whenever you use Welch's method and you do the problem by hand instead of on the calculator is you get a little bit wider of an interval. So like negative point, you get the upper bound, I'll get the lower bound.
Okay.
Okay, so I got negative 0.5577 for the lower bound.
And then 0.0777 for the upper bound.
Okay. Notice this interval is slightly wider than the interval Allison got for us on the calculator. Anytime you use the calculator instead of doing it by hand with Welch's method, the calculator gives you a smaller interval. See how it's like in there?
Yeah, so it's more more accurate.
Well, it's a nicer, yeah, it's more accurate for one thing because you're not rounding the degrees of freedom. And it's more narrow, which makes it a more useful confidence because it's more narrow, but we didn't change the level of confidence.
Right.
One more thing I'll show on the calculator, when it actually goes through the whole thing and does the degrees of freedom without using Welch's method, notice that the degrees of freedom is going to be a little different than ours, getting 9.69.
Right.
We use, so that's why your answer is a little different than the calculator.
Yeah.
Happens all the time.
Yeah.
So good. You are so good. I love it. So like you love math so much, and I know you use it all the time on the set.
Yeah. Constantly.
So, yeah. Well, thanks for taking time to help our students with their daily math as well.
I really do love math. I really think it's amazing, and this was very, very fun. Maybe I should invest in a big time calculator. You know?
Oh, girl, I got you. I got a drawer.
Probably.
I got you. Just give us your address. We got you. Okay, cool. We know what Allison's thank you present is. Okay, we're not going to take up any more of your time, but you're a doll.
Okay.
With you, and I will mail you later with the info.
Thank you.
All right, yay. So nice to hang, guys. Have fun.
Bye, Allison.
Okay. This next band is from Toronto, and yeah, give it up for Sex Bob
Scott, you ready? Okay. Kim, are you?
I'll take you for a ride. I'm a garbage truck. Oh no, take you to the dump, 'cause you're my queen. Take you uptown, I show you the sights, you know you wanna ride on my garbage truck. Truck, we'll pass the mansions by, drive right through the needle's eye. Oh my, my. I got a stereo, you just gotta turn the knob, and baby we'll go as far as we can. I'll be your garbage man, I'll take out your junk, and I'll